Okay, we're back. Main shaft time. I just pressed the little gear off. I'm going to use it on the other shaft. I'm not going to use this shaft, but I'm going to straighten it best I can anyway. Okay, this was I think 4 thou, 2 thou, I think. That's what it was. 2 thou. Let's go see what it really is. It's out. We don't know how much. We just know it's bad. Okay, we're going to check it on this side here. Okay, there is our air. A little low on the one side. It's 50. 1, 2. And I dropped one under, so that's 3. It's a solid 3, maybe 3 1/4. One, 2, 2.5. 1, 2. What do we got here? 1, 2, 3. That's 3. Okay, that's 3 on this side. I don't think it's bent here. I think it's bent over here. So I'm going to run it over the other side. See what it shows on that other side over there. Pretty consistent. One, 2, 3. It's about the same. Come on, pick a number. 1, 2, not quite 3. So it's pretty consistent all the way across the whole thing, which means it's probably bent here in the middle, not here. So I'm going to do a run sweep test, length test, and just see what I see. Don't tripod little camera with all these heads over here. Cylinders. Okay, we're going to play around this here a little, blow this up so you can kind of see a little bit what's going on right there. Alright, let's see what we get here. Oop, go until you hit something. Okay, we're on the top. Lock it in so it's tight. I grew like 4 or 5. That's about 5 thou growth there. 80. 4. 5.5 thou. That's a lot. Then we rotate it, we don't get that much, but going linear you do. Okay, so you mark that right here. Okay, so I'm going to go up on top of the worn area, which is going to be kind of a hit and miss on the dimension for that one, obviously, but yeah, that's terrible there. This surface is so bad, it's ridiculous. It's dropping as we go this way, so. Okay, this is the worn area. One dial, two jump, stays the same. So that's within one or so right there. Can't measure that as junk. That's straight. And over here, it's not moving. So all our air is down here, so it's bent here. That's where all the air is at. This air here is because it's bent here. This is pretty straight here, so it's good. I don't know. The taper must be bad in there, that's why it's flopping around, because it's not bent down there. This is our air right through here. 5 thou. I'm not sure why I'm not getting, when I rotate it, I'm not getting that, but we rotate the high spots right there. Not there. Okay, that's our high spot right there. Alright, I'm not sure how much this is going to move by beating on it, so. Oop. It moves when you hit it. Oops. You don't know what it's going to do until you hit it, right? Okay, we're gaining 5 thou. Still are. Didn't change much. Hit it harder. Ooh. That moved a bunch. That made a difference. The wrong direction. Concussion wave sucked. Tighten this thing up more. It moves too much. Yeah, that didn't help anything. 8 thou out. So the concussion wave made more damage than what we had initially starting with. We only get a couple thou when you turn it, which is weird. I wonder if this has got a big taper. I didn't check this for taper. I should have done that. Dumbass. It's definitely high there. I'm only getting a couple thou when I turn it. Yeah, this is probably worn a lot. So this shaft is not very good, so. Let's go measure it. See what we got. Hey, you're pretty close. Down here somewhere. Yeah, about that much. How close that was by guessing. All right. All the way over there, we're at 3/4 under, half under, 2/10 under, 2/10 under, 0, 2/10 under. So we're not getting a lot of taper in this. I don't know why the indicator is measuring a lot of taper, yet we spin it, we don't get it. That does not make any sense to me at all. Yeah, I don't understand that one. Makes absolutely no sense. There we go. Now we're getting some dimension on that thing. Now we're going to get a solid 3.5. And the high spot is right there, which is the same spot it's been. So that's consistent. You're not watching me. You're supposed to be watching over here, dumbass. So, see the needle goes up and down there, if you can even see it. Okay, so we're going to go with the press and do a little pressing action, because beating on it does not seem to be helping us at all. You don't run the chip carbide against it. It hurts the carbide. Alright, we can go over here to our handy dandy press. Get back over there, we can see. Alright, I'm not sure what number we're going to use. Back down out of there, that's for being sure. There we go. In fact, we can kind of see what's going on a little bit. Okay, we need to get over here and press on this. So I'm thinking I'm going to put the aluminum right there. And a piece of, ooh, that's steel. So I'm going to put the aluminum over here. Steel against that piece of crap where it's bad. We'll go way over here out of the way. And we're going to take our pressing block that's previously damaged. Press on that sucker. Okay, we need a little bit more elevation here. Here's some elevation material. All right. I'm just going to press right on that actually. All right. Not quite where I want it to be, but that's where it wants to be. It's definitely sliding over as I did that. All right, it's a couple tons on that, not too bad. We don't know what it wants until we do it, so we got to figure out what the sweet spot is. Got to sneak it up on it. I knew on the other one what the sweet spot was. 17.5 tons have the sweet spot. Same spot. 2 to 3 thou, depending on what it wants to give you for a number. Needs to be more on this side of the line. Okay. So that was a couple tons. Did I put on, or 3 tons, I think? So we're going to go up to 5 tons, I think, over here, and that's probably going to be a ton too much. Literally. This is pretty uneven here, pushing on this damn thing. Okay, well that's way over there. That's coming off the edge of the block. I don't like that. That's dangerous. Okay. Tonnage. Flash to 5, 4.5. Let's see if it moved. Seemed pretty solid, so I don't know if it moved. If it moved, it didn't move much of that. Pretty firm on that 5-ton deal. No, I didn't do anything. It's in a different spot. Yeah, it's on the other side of the black line this time. Yeah, right on the line, just to past it. Mark is still where the high spot is. Okay, that was 5. So it took 7 or 9. It took 9 to move that other one, and that was smaller diameter than this one. But this is a lot longer length, so it shouldn't take as much tonnage to bend, even though it's bigger diameter. But you don't know until you do it. That's the thing about this. Everything is unknown until you actually do it. Then you find out that you overdid it. This goes back over here. Keep bending there up on that. Okay, this is going to go over here someplace. Find the sweet spot. Put you into there. Get up in here a little bit. Really want to be over here. Perfect. Okay. So our line is just past the center where I want it to be. There's our tonnage. Crank the handle up for high tonnage. Less work for me. Sliding over. See how it's rotating this way? It's in the wrong spot. Got a lot of bending going on here. There's a tonnage right now coming in. That's a little over 6. So this is rotated way over from where I don't want it. So I'm going to release it, rotate it to the other spot, and see if it'll stay on the other spline. Put the same 6-ton on it again. That should bend it on center where we want it to actually be at. Okay, yeah, we're doing it this time. This time it's staying where I want it to be. Okay. Now it's 6. There's 6.5, 7. Okay. And we're on a correct spot. And that'll actually nick the material a little bit doing that. But see how much it was bowed? Big spring. She had some springiness there. Had some pressure on it. She gave up a bunch when you kicked her over. Alright, let's see what we got. Did it move a lunch, or did it not move at all, or is it right on the money? I think it should be pretty close. There we go. And the answer is, the dumbass got it close. Twitch, twitch, twitch. It's not really moving. Once again, the indicator does work, see? It's not a fake video. It is consistent. It's being straight. Let's go over here and check over here where it belongs in the bushing. It's not doing squat. And actually that's the bearing area right there. It's straight. Okay, I'm going to go over here to the other side and see what it is over here. That's where the other bearing is, obviously. Right in the middle of that bearing area. So, okay, we got a little bit on this side. You got a little bit of something right here. That's in the self-aligning bearing, and low gears right here, but I can live with that, I think. I think I'm okay with it. I don't like it, but it's... I don't want to try to get that out. It's a lot longer shaft, so you can tolerate errors, because you're supported way... Remember, the high gear is way over here. The trap door bearing is right here. This is the roll, or it's actually the bearing's right here. The clutch sits out here. The bearing's right here. Just the needle bearing here. You can see your... Here's where the bearing's out. Needle bearing's right next to it. That's the case bearing. This is all the tranny sticking out here. So you got bearing. The other bearing's right here, right next to it, and then the bush is way out here for the clutch. So this area here is the important part. This is important too over here, but it's less of importance. Alright, so I'm good with that. This shaft is really bad condition though, so being a thaw out ain't gonna hurt it any. So it took 7 tons to straighten this one. It took 9 tons to bend that one, and it took 17 tons to bend that one. There you go. Now you know how to do it at home. I gave you the tonnage. You got the secret number. The recipe for straightening your shaft when they get bent. This hammer's not big enough to do that. This is not supported adequately either. Too much flex. But alright, there you go. I got 2 shafts I could put together with that, but I am not going to do that. This one I might use. I'm thinking it's probably okay. I'm going to look at that taper real close in there, the radius in here. It's called a fillet, but I think it's pretty good. I heard a little pop on something, but I don't know what that pop was. There might be a hairline crack in it somewhere. If it breaks, it breaks. That's how it works in the big city. Otherwise, I got to pull out my brand new counter over there, which I don't really want to do. Or I can use a stock looking one, which I really don't want to do either. So, if I was smart, I would probably change this out, because this is pretty worn through here. It's not in best condition. And leave this as a mock-up for a non-race application. You can run this in a short, just a regular bike application, no problem. This will run just fine. For a racing application, like I'm doing, it's probably best not to use it. It's called cycling the parts out. And they definitely need to be cycled. And then it just becomes, do I put the brand new one in there and use it, or do I put this thing here back in if I decide not to use that? So, I don't know. We'll make a decision. Tomorrow we'll find out, because that motor's going to go in that bike. That's the plan tomorrow. Alright, that's it for now.